Hello everyone. So in this session I'm gonna take you through the flow simulation on stop valve assembly. So before we had gone through ball, uh, this is the setup of assembly which we are going to work on. So we'll consider inlet flow of 0.9 meter cube per second to account, and we'll simply deal the outlet as the environmental pressure, and considering the goal rates of volume, flow rate, and the velocity. I'll just describe how to deal with the setup. I'll just create a new project naming as stop valve flow analysis. Okay, later on you can set the unit system here. Pressure length should be in millimeters. I'll keep. Okay, so later on you can just deal with these all the unit systems. If you want, you can change it, and flow should be internal here. If you want to define a gravity, that also can add it. So gravity should be downwards. I'll choose the liquid as my reference here, that is water. Flow type laminar and turbulent. There are sets, can set it up to laminar only or turbulent only, but I need both the cases into account. I'll select both. Roughness, if you want, you can specify as 0.05 micrometer, and the flow should be adiabatic for me. And finally, the potential and the pressure, I won't change anything here. If you want to define the inlet velocity here, you can define it, otherwise we'll define it here. So this is the setup. Okay, once you set up, automatically computational fluid domain gonna added. So if you want to modify that one, you can by utilizing the braggers. Otherwise you can use the manual method by setting up these things. Okay, so once you're done with that, you can simply hide this one. And to get better results output for this particular stop valve, you need to refine your mesh. Automatic method, you can set it to level 7, or in the manuals you can set here at this region the coastal mesh. That's your mesh. And boundary condition, I'll define the inlet volume flow of 0.9 meter cube per second for inside face. Okay, same thing for this side. To avoid just complications, I'll just activate the transparency, and here you can easily choose the inlet. So I need to define the outlet here. Outlet pressure, I'll keep it as environmental pressure. I'll select this phase into account. Okay, and finally, to set the goals, I'll define the goals. The global goal should be total volume flow rate I need. Okay, And for the surface goals, I'll define the surface and the surface to account, and at that region it should create goals for each. And I need here the maximum and average velocity. Okay, yeah. If you want to add the volume flow rate also, you can define it. So once you set your boundary conditions, you can directly run the study from here. Otherwise you can choose this run options. Okay, once you're gonna run that, you're gonna get the results. So I'll just go to that. I'll simply load the results. Already ran the study, and here I'm gonna turn the transparency of this also to okay. Now the results, I'll activate the cut plot. I'll create one more for me. I'll choose the reference plane as right. Okay, and here if you want to see the velocity distribution, you can have it, or if you want to still refine it, you can increase the number of levels, and offset if you want to have it. You can simply utilize the drag button to check how it is distributing at the ends here and the that regions. Otherwise you can set it to 0. Okay, so if you want to add the streamlines, that also you can do, or if you want to check the vorticity, you can do check that one. Sorry, here I'll add the vorticity, and here I'll keep it velocity, and the spacing should be less, the width also should be less. No, this is minimum. Yep, fine. So there are many vertices, and then we have the option to deal with the ISO lines. If you want to increase the ISO lines with respect to velocity, that also can increase here. See, right? And vectors, as you already know, how the flows are happening, it will showcase. Yep, this is one for velocity. I'll just activate this one. I'll just hide it for now, and you can just show this one. So this I'll check. So pressure distribution. Okay, so this is how the pressure distribution is there inside it, and if you want to stay the streamline, this is how it is. ISO lines with respect to pressure. Okay, and finally to deal with this particular flow trajectories, I'll simply make the changes inside. I'll just click on show. I increase the number of points, and the size should be less. We'll make it 0.001. more. Let me just decrease to 200. Okay, I'll just use this one and I'll just animate this. How the flow is taking place inside. What I'll do is I'll simply remove this appearance for now. Now we can have a clear look. To have a more finer flow, I'll simply again increase the size of it to 0.002, and let me just see. Instead of arrows, I'll utilize the pipes. The size I'll increase it to 0.001. Make it 100. So is quite this is okay for me. I'll just use this. Yeah, finally to just check the results. We can have a goals. From there we can utilize the goal which we need. I'll select both and it will showcase the average velocity. The maximum is 0.83. Okay, sorry, this is minimum value and this is maximum value. Yep, that's all about the study. Thank you. Stay tuned.